Hi guys, in this video we're going to go through some of the harder fraction examples that I found in the textbooks and on Education Perfect. So one of the first questions I need to sort of cover is how are we cancelling these terms? So if I have 5 over 5, well that's equal to 1, right? Or 1 over 1. There's 1 5 that can fit inside 5. So if I have an x over x, that again is equal to 1. Or 1 over 1. Now here I have 2 times 3 and 2 times 5. I'm making this 3 2 times bigger and this 5 2 times bigger, so I'd end up with 6 over 10, but that's still an equivalent fraction to 3 over 5. Those 2's are actually cancelling out the effect that they have. I get twice as many slices down the bottom here, but I also get twice as many of them, so that the effect of them is actually cancelling themselves out. And so here in this equation, I'm making my 3x times bigger, but I'm also making my 5x times bigger. So as much as I would have 3x over 5x, that multiplication there is still cancelling itself up, and I end up with 3 over 5. So we can cancel out terms when they are multiplying, okay? But it's only when they're multiplying. We're making them 2 times bigger here, we're making them x times bigger here. So here in this example then, it kind of means the same thing. I actually just have multiple multiplications going on here. X to the power of 3 is the same as x times another x times another x, and that's over an x times an x. Now, here I'm actually doing I'm using both of these examples. Here I'm making this group x times bigger and I'm making this group x times bigger, and so their effect is actually cancelling themselves out. But we also, if we look up here, we know that x over x is the same as 1 over 1. So they cancel each other out, and it leaves us with something like 1 times x over 1 times x. And then if I cancel out the next ones, then we have 1 times x over a 1. And in the end, everything cancels itself out, and we're just left with an x. So what about when we have a plus or minus? That's a little bit trickier, because it's not multiplying anymore, we can't just easily cancel things out. We can only cancel things out when we know what they are, or if they're the same thing because they're having the same effect. However, if we see this 6 at the top, a 6 at the bottom, and a 3 also at the top there's something going on. It looks like we could actually take out some common factors. So we know that a 3 goes into 3, a 3 goes into 6, and a 3 goes into the 6 here. So I can look for a common factor and factor it out. So here, if I factor out a 3 in this top numerator here, I can take out 1 3 here and 2 3's here, and I'd end up with 3 times x is 3x, and 3 times negative 2 is negative 6. And now this 3 here is multiplying with the x minus 2. And so I can look at how I can cancel out that 3. And I can do that because there is a common factor here. There is 1 3 here and 2 3's here. So that'll cancel out, that'd become 1, and that would cancel out and that would become a 2. And so now, because my 3 is multiplying, I end up with an x minus 2 over 2. Now I can't simplify that any further because there's no more common factors. There's no 2 up here, so I can't actually do anything more. My final answer is going to be x minus 2 because of that subtraction over 2. And sorry, here's just an explanation of what I just told you. So what about this here where we have brackets and these additions? Well, surely that's the same as 10 over 10, and so they would cancel each other out and we'd end up with 1. Or what about this one here? X plus 3, x plus 3. Well, again, it's in brackets. They're the same top and bottom, and so they are actually cancelling each other out because they're multiplying by a 1 in both cases, and they would cancel each other out because it is a multiplication when they're in brackets. So when we have terms grouped in brackets, the plus or minus sign can be involved with factoring out. So for example, we have a large fraction here, but we can see we've got common factors top and bottom. We have a 16 here and a 16 here. We have an x here and an x here. We can factor these common terms out of this expression. So if I divide both of these by 16x, I would end up with a 16x on the outside, and inside I would be simply left with an x to get that x squared, and here plus 1, because 16x times 1 is 16x. And that's going to be over, now here I have a 2 and a 2, so I can factor out that common 2 from both of these terms, a 2x plus 1. And now I have all of this x plus 1 in these brackets multiplying by this 16x, and all of this x plus 1 multiplying by this 2. That now can be factored out. And so I end up with 16x over 2. And again, I can go further here. I've got 16 here, 2 here. The common factor, highest common factor will be 2. And so we have 8x over 1, which is just 8x. Okay, so here are some awful examples from the Walker 1.2 book. We'll start off with 15y over 2x divided by 3y over x. Now we've got to remember the rule for dividing fractions is actually we're going to take the reciprocal of the second fraction and we're going to multiply by it. So I'm going to rewrite it. I've got 15y over 2x, and now I'm multiplying by x over 3y. Now I can just simply do the multiplication, and we just got to remember now that we multiply across, and so I will end up with a 15xy over 6xy, and then these y's are cancelling each other out, these x's are cancelling each other out, and the highest common factor here is 3 that I can divide by, and so my final answer is going to be 5 over 2. Okay, in this example we have a subtraction, we have the same denominator, but we do have some brackets we need to deal with first. So I'm going to have to expand out these brackets, and so I'll have 5 times 2 is 10, so 10x, and then minus 15, and here I'm taking away 4x minus 3. So I'm taking away a negative here. What's going to happen is this positive, because there's a negative in front of it, is going to flip to a negative. But because there's a negative in front of this negative here, this minus sign, it's actually going to turn it into a positive. So when I rewrite this, I'm going to have 10x minus 15, here's our first part, now minus 4x here, and minus negative 3 becomes plus 3 over 12. Now I can just group my like terms, so I've got 10x here, I've got another negative 4x, so those will be grouped together, and I'll have 6x, and then a negative 15 plus 3 will take me to negative 12. So now I have 6x minus 12 over 12, and as much as there's a minus sign here, and so I have unlike terms at the top here, I can simplify further by taking out a common factor, because I'm seeing a 6 and two 12s here, and I know that there's common factors between them. So the common factor on the top here is 6 that I can divide by. I can take out a 6 by dividing out by 6 here and divide by 6 here. Okay, and that will give me a 6 on the outside of the brackets, and then an x is left inside because I need to get back to 6x. 6 times x is 6x. And here, if I divide by 6, I'm left with negative 2. And that's going to be over 12 to begin with. Now, I have got some more common factors here. I'm multiplying this 6 by what's in the brackets now, so I can cancel out that 6 by dividing it by 6, and if I divide this by 6, I'm left with 2. And so my final answer is going to be x minus 2 over 2. Now, there's no more common factors here. I've factored everything out, and so this is my final answer. Okay, this is a very similar one. However, we just got some more sign flipping going on here. So first we'll expand our brackets. So 6 times 3 is 18. 6 times negative 2x is negative 12x. Okay, that will be what this I see on this side. And then over here, now we have minus a positive, so this will be a negative x. And I'm also taking away this positive, so that's going to become a minus 5. So when I rewrite this, I have 18 minus 12x minus x minus 5. Okay, and that's all over the same common denominator now of 13. Again, now I just look at my like terms. Now the 18 is first, and it's taking away the 12x. So that means I'm going to leave the number here in front. So I'm going to group my 18 and my negative 5 together. So 18 minus 5 is 13. And here I have negative 12, take away another x will be negative 13x. So again, you'll see some common factors happening. We have 13 minus 13x, and that's all over 13. So I can again take out that 13 by factoring it out. So I'm going to divide both terms by 13 here. So 13 divided by 13 is 1. So 13 goes on the outside of the brackets. I'm left with 1. And then negative 13 divided by 13 is negative 1x. And so instead of putting a 1 here, I'm just going to put an x. And that is over 13. And now that I have a 13 top and bottom, and this 13 is multiplying, it will cancel out. And my final answer is just going to be 1 minus x. Okay, in this one here, I now have a whole number adding to a fraction. And so to be able to do that addition, I need to turn my 3 here into a fraction. Now we should know by now that the simplest way to take a whole number and turn it into a fraction would be to take that 3 and put it over 1. Okay, but that would leave me with a different denominator, and so I'd have to multiply it anyway, so I'm going to go straight to doing that. If I want it over 5 here, I need to multiply it by 5 top and bottom. So my fraction that I'm going to end up with is going to be 15 over 5, and then I'm going to add that to my x minus 2 over 5. So now that we have a common denominator, we can just write it all as one fraction and group our like terms. We have a 15 and a negative 2 here, and then just a positive x on its own. So we put them together and we end up with 13 plus x over 5. Okay, so here's now a harder example from Education Perfect. Oh, and we can see that we have powers of powers and they're in fractions. So we're going to have to work through, first of all, by dealing with these brackets. So if we remember with our powers of powers, we're going to deal with the numbers first and just do the straight power of 3. And then we need to remember that we multiply any powers inside the brackets by the power outside the bracket. So working down the page, first 3 to the power of 4 is 81. And then r to the power of 3 raised to the 4th is going to be r, then 3 times 4 is 12. And then t, which is to the power of 1 here, is just going to be now t to the power of 4. Okay, again, numbers first. So 2 squared is 4. And then r squared to the power of 2 is going to be 2 times 2 is 4, so r to the power of 4. Alright, on this other side here, 2 to the power of 3 is 8. And then r to the power of 3 and t to the power of 4 times 3, which is t to the power of 12. And there's no powers of powers here, we can just write this 9rt to the power of 3 underneath. Okay, so now if we just look at this, it's actually going to get a little bit tricky. We don't really want to deal with these multiplications the way they are, because 81 times 8 is a little hard to do without a calculator. Of course you can do it to the side, but we're going to start dealing with these big numbers and it's going to be hard. But what we can do is still factor out any common factors, because if we look at the top and bottoms of both sides, because they're multiplying, we can look for common factors. Here we've got an 81 and we've got a 9, and we know that 81 is a multiple of 9, and so we've got a common factor here. So we can actually turn this 81 into smaller numbers that are multiplying each other. And here again, we've got a 4 and an 8, and we can actually break them down to numbers that are multiplying as well. So first of all, I'm going to take my 81, and I'm just going to rewrite that as 9 times 9. Because 9 times 9 is 81, and then we have 9s at the top, and we're going to have 9s at the bottom when we're done with this. Okay, now the 4 and the 8, I want to deal with them as well. Now, I might as well just break down this 8 into 2 times 4 and leave my 4 at the bottom, because then I will have a 4 at the bottom and I have a 4 at the top. But 2 times 4 is my 8, so that's where that comes from. And finally, my 9 will stay down the bottom because I don't want to break that down any further. I want that common factor with these other 9s here, and I want it to be the highest common factor. So one more time, I take my big numbers and I just break them down into factors. And I'm looking for a common factor at top and bottom. And because we're multiplying, it could be anywhere along the bottom. So 81 and 9 go well together. And so I'm going to turn my 81 into a 9 times 9. And here, my 4 and an 8, well, I can turn that into 2 lots of 4. And then those 4s will be able to cancel themselves out. So now I'll just write the rest of it back in there with it. So I've got all my working there, and I can start working through those. So when I cancel out this 9 here and this 9 here, I'm left with this one last 9 at the top. So that goes down here. Okay, and now let's look at my other factors. So I have a 4 here and a 4 here, so they are going to cancel each other out. So I'm left with no 4 at the bottom, and I'm left with just this 2 at the top here. And now I've got no 9 down the bottom on this other side as well, and so now all my numbers have been dealt with. I'm left with just that 9 and a 2. And again, I'm just going to rewrite the rest of this r to the power of 12 t4 so that we've just got our working in a nice tidy way. Of course, you can start putting these together a bit more once you're used to doing it. So now I'm actually going to do that multiplication. Okay, I could start factoring out more here, but I'm just going to do it once at the end. So I have numbers first. 9 times 2 is 18. And then r to the power of 12 times r to the power of 3. Now that we're multiplying our powers, we know that the rule is that we add them. So it's 12 plus 3 is r to the power of 15. And then this t to the power of 4 times t to the power of 12. Again, remember the rule is we're adding now when we have a power times a power. And so it's going to be t to the power of 16. And then down the bottom here, r to the power of 4 times r is r to the power of 5. And then that t has nothing over this other side, so it's just going to stay as a t to the power of 3. Now all I've got left to do is to start cancelling out any like terms. So there's an 18 at the top, but no number at the bottom, so that 18 stays there. And then I've got an r to the power of 15, so I'm going to get rid of 5 there, and I'm left with 10, and those 5 are gone. And then with my t here, I'm going to cancel out these 3 here, which means I'm getting rid of 3 here, and I'm left with 13. And there is my final answer. So the lesson from this last one here is when we're doing these big multiplications, we can actually start trying to break down numbers into their common factors and factor things out first to make it easier. We could get there in the end by doing 81 times 8 and 4 times 9 and then dividing it, but it's a lot trickier. If you know how to do this trick here and break it down, then it is a bit easier.